Anu has a flask of denatured alcohol, and she's pouring that into our flame dish. She's going to light it. And now she's putting on the top part of our experiment. And what we're doing today is we're actually creating a fire tornado, a fire vortex, fire-nado. It has all of these names. And these actually occur in nature. They're often 1 to 3 feet in diameter and 100 to 300 feet tall. Sometimes they even reach the same wind speeds as a tornado, for example, an F3. They're known to actually grow to be more than 1 mile tall. The one that we're doing today here, you can see it's starting to form. It's really exciting. You can see how the fire is starting to walk around that center dish. It has a little bit of a wag to it. And the way these fire-nados or fire tornadoes actually form, it's about the physics of fire, about how hot air rises and cold air rushes in beneath it to replace that space. And when you have the right aerodynamics in place, for example, at the base of our demonstration lab equipment, you actually start to get this rotation of air that's coming in, and it's creating these air eddies that allow the fire to actually start to walk around the dish. And when these form in nature, they're often in areas that are very flat, where you can have these kinds of eddies form. The most famous fire tornado happened in Asia when there's a chemical spill on water. And there you actually had a fire tornado that was 1 mile tall. Here, it's starting to go. I don't know if you all can see that or not. We have flames that are about 3.5 feet tall. And if you look at the base, you can really see how the air is whirling. You can see it dancing on the dish and at the base. You can see the streaking.